Now, Americans recycle increasing amounts through municipal waste collection. As you see here, the municipal waste collected, they collect paper, metal, glass, plastic. Some of them are recycled and the other are not recycled. The table shows the collection data for 2007. What is the probability that a sample of recycled waste is paper? As you see here now, we have 45.2 million of tons paper are recycled and 37.8 million of tons of paper are not recycled. So this number, each number here presents millions of tons for the waste collected. Now, what is the probability that a sample of recycled waste is paper? So here, as you see, we have a table that show the municipal waste collected. Now the question is, what is the probability of a recycled? Now look at the question here. The probability of recycled paper recycled is paper. Now sometimes the conditional probability can be written like this, and sometimes it can be written as A or A given B, or B given A, or recycled is paper, like A that happened, B will happen if A will happen. So here, when you said, what is the probability of, like this one here, 4 year, that the chosen girl is 4 year and male, you will put it as 4 year dash male, or the probability of the chosen 4 year students are male. Here, what is the probability that of recycled waste is paper? So what is the condition here we have? The condition that, is it a paper? Shall we write it like probability of paper given that it is recycled? Or the probability of recycled given that it is paper? What is the condition here?
Of recycled, given that it is paper.
Yes.
No, I told you. No. I will repeat it. Here, they ask me, what is the probability that the sample of recycled is paper? So what is the condition here?
That it is paper.
The condition. And is it paper or is it recycled?
It's recycled.
It's recycled. The condition here, so I will write it as the probability of paper given that the given paper is recycled. So there are two ways to write the probability. We can say, what is the probability of event A given that B occur? Or what is the probability of B that what is the probability of B that is A? Like the condition here is B. So I can write it as the probability of paper given that it's recycled. Because the condition here that is it is recycled. So we write it as the probability of paper given that it is recycled.
Teacher,
Yes, Rose.
teacher, like we always make the condition in the second event, like this.
Sorry?
Like we always do the things that are in condition, like recycled, always like this. Or only in this question.
According, I told you here you have two statements. If they told you what is the probability of paper given that recycled, it's already ordered. You will say it is paper given that recycled.
Yeah.
So this word given shows me the order that is correct. Paper is recycled. Here, no, here they told me what is the probability of recycled is paper. There's no word given. Given, this told me that the condition here is recycled. But here, word given is not written. Here, the recycled is paper. So you have to change the order.
Okay, no, I understood.
Which is
Thank you,
paper
teacher.
is recycled.
Okay, teacher, thank you.
You're welcome. Yeah, let's continue now. What is the probability that it is paper given recycled? As we said, it is the probability of recycled and paper over, here we end with recycled, so over the probability of recycled. Now, recycled and paper, how many?
45.2.
45.2 over the probability that they are recycled.
We need to add up all the recycled items.
Exactly,
These
you
are
have to add all
79.4.
of these numbers. 45.2 plus 7.2 plus 3.2 plus 2.1 plus 21.7. Let's now add them.
It is 79.4.
So let's write it here. Okay, so 45.2 over 79.4. Then after you simplify, you will find that the answer is 0.575 or approximately 6. So 57.6% or 0.576 thousandths the probability that the recycled waste is paper. Is it clear?
Teacher,
Yeah.
Yes.
you wrote it 45.7, but it's 45.2 over 79.4, and that is 0.569.
Answer will be changed. Okay. So here, what's the final answer was? 79.4.
Yeah,
And after division, there will be
0.569.
6.
And so it's
Okay.
about 0.57.
Okay, so it's 56.9%. Is it clear?
Yeah. Yes.
Let's solve now, got it too. That is also related to this question here. We have the same numbers. What is the probability that a sample of recycled is plastic? Since a word given here is not written, so we have to change the order. So, probability of recycled is a plastic, while a plastic is recycled?
Plastic is recycled.
Bravo. Plastic is recycled. So it is the probability of plastic and recycled over probability of recycled. What is the probability of plastic and recycled? Plastic and recycled. It is 2.1 over the probability of recycled, the one that's Hanin added before, 79.4. So let's divide them now. We'll find they are 0.026 or 2.6%. Is it clear?
Yes.
Yes, teacher, but please don't erase it. Just a minute.
Yeah, okay. Now let's solve B. What is the probability of recycled is a glass? We have to do the same steps here, but changing the numbers. So instead of plastic here, let's write glass.
Okay, teacher, I'm done. Thank you.
You are welcome. And here, instead of plastic and recycled, let's write glass and recycled
0.2
over, okay, sorry. So glass and recycled, it is 3.2, bravo, over 79.4. Which is 0.04 or 4%. Do you have any question?
No,
No.
thank you.
Okay. This one we solved yesterday. Yalla. Here. This is number 20. Suppose now A and B are independent events. Well, probability of A is 0.6 and the probability of B is 0.25. Find each probability. First, so here we have probability of A, it is 0.6, and probability of B, it is 0.25. Find the probability of A and B. What we have to do if we have A and B for independent variable?
Multiply them.
Multiply them. Thank you. It is the probability of A times probability of B. So we have to multiply 0.6 times 0.25, which is 0.15. This is probability of A and B. Now, let's solve number 2 now. In number 2, we have to find the probability of A given B.
Over B.
So, probability of A given B. So what you have to do say here, it is the probability of A and B
Over B.
over probability of B. Bravo. Where is probability of A and B?
0.15.
It is 0.15, which we found it before, over the probability of B,
0.25.
0.25. So 0.15 over 0.25, it is 0.6.
Teacher,
Yes.
here we're not going to count them because this is dependent, not independent.
Count what?
A and B. because here it's an independent, I mean dependent, not independent.
So,
Right? So we are not going to multiply them, but add them, right? Like 0.60 plus
this is
0.25.
this is and يعني multiply.
Oh yeah, because sometimes we
Or.
add them.
Or it is plus.
Only or, right?
Yes,
Okay.
and it's multiply.
Okay, thank you, teacher.
You're welcome. Is it clear?
Yeah.
Yes.
Now let's go to problem number 3. Here, as you see, they asked, the company asked 50 of its customers whether they pay their bills online or by email. What is the probability that the customer pays the bill online, given that the customer is male? Look at this question here now. That the customer bill online, given, so it is ordered here, given that he is male. So we have to say the probability of online given that he is male. As you see now, they found that 12 of the males buy online and females are 24. Males, we have 8 males buy by mail and 6 females buy by mail. Now, what is the probability that online, given that they are male? Online, so we are talking about online, given that they are male. So what we have to do here, it is the probability of male and online over the probability of male. Yeah, what is the probability of male and online?
12.
12.
Over male. How many males here we have?
20.
12 plus 8, which is 20. So we have 12 over 20, which is 0.6 or 60% of male of online, of the bill online, given that the customer is male. Let's solve now. Oh, before that, is it clear?
Yes.
Yes.
Yeah.
It's easy. If you have a given, just write or just translate the words into the probability. If it is no words given, change the order. Here we have researchers. They asked the shampoo users whether they apply a shampoo directly to their head or indirectly using a hat. What did you prefer, to put a shampoo on your hand or directly on your head? This is the survey. They asked that 2 males would like to apply directly the shampoo into the head and 18 males into the hand first, 6 females into head and 24 into the hand first. Now, what is the probability that the respondent applies shampoo directly to the hand, given that the respondent is female? So here, what is the probability applies shampoo directly given that female? It is the probability of directly and female over probability of female. What is the probability that is they apply the shampoo directly and female?
6.
6, bravo. And they are female?
30.
30. So we have 3 over 10. So it is 0.333 or 33.3%. Is it clear?
Yeah, thank you.
Yes.
Now, so I told you that the objective from this lesson, how to find the conditional probability by the table and by the tree. Let's see now here,
Teacher?
how can we solve it by the tree diagram? Yes, Rose?
I'm Haneen.
Haneen,
In 6 over 30, isn't it 1 over 5? And so it's 0.2.
Is it? Yes. طب أنا شو عملت؟ Divide by 3 and up divide by.
Because 6 by 3 was 2.
It have to
So
be
it's
2
2 over
over 10. Okay. So they are 50%. Thank you. Yeah. Here now. Using a tree diagram. A school system compiled the following information from a survey it sent to people who were juniors 10 years earlier. Now let's see how can we first how we draw the tree diagram. 85% of students graduated from high school. So here we have 85% are graduated from high school. And I will write them like graduated. Let's write them as G. So if 85% are graduated, how many one didn't graduate? We have to say 100 minus 85, which is what?
15%.
Just 15. So if 85% graduated, 15% didn't graduate. Then, of the students who graduated, let's talk about now, let's go to the branch for whom graduated. Of the students who graduated from high school, 90% are happy. So here we have 90% are happy. So if 90% from the graduated are happy, how many one are not happy?
10%.
10%.
They have to be 10%. Let's see. And of the students who didn't graduate from high school, let's go now to this branch here. 60% are happy. With their present job. So if there's 60 are happy, we have 40% are not happy. This is how we draw the tree diagram. Shall I repeat it?
No, thank you.
Okay, let's draw it here. So let's now convert the percent to be as a decimals. Let's see now here we have 0.85 and 0.15. These are graduated and these are not graduated. Then 0.9 are happy, and 10%, sorry, 0.1 they are not happy, and we have 0.6 are happy, and 0.4 are not happy. Now, what is the probability? Before that, let's talk about the T diagram. I want you now to know that this number that is written on the T diagram here, okay, shows the probability. يعني number 0.9 as an example is the probability of graduated and happy. This is not a number for the conditional probability. This is for and. So the table here shows, like, did you remember in that the tables, the number that is shown, show me or tell me or present the number of the probability of A and B. Here the numbers on the tree diagram shows me also the probability of A, of G and H. I'm sorry, I'm saying something wrong. I'm still sorry. Here, I'm sorry. The numbers that on the table shows I will present the probability of A and B. For the T diagram here, this number shows the probability of H given G. So the numbers here tell me about the conditional probability of H given G, or of not happy given G. So this 0.1, this is the probability of not happy given that graduated. I will come back. Not happy given that graduated, 0.1. Happy given that graduated is 0.9. Happy given that not graduated is 0.6, and not happy given that not graduated are 0.4, or is 0.4. So be careful, not G given H, this is H given G. So the numbers on the branches shows the conditional probability, or represent the conditional probability. Is it clear?
Yes.
Yes.
The numbers shows the conditional probability, but on the table shows the B or A and B. Now, what is the probability that a person from the junior class 10 years ago graduated from high school and happy? Now, before this question, if I'm asking you now, what is the probability of not graduated or not happy, given that not happy are given that he's graduated? What's the answer? Or what is the probability that he's not happy given that he's graduated?
40%.
Not happy given that
It's
he's
going-
graduated.
It's going to be 10% over
Yes,
90%.
or 0.1. So you have to say this is 0.1. This number here, not happy given that he's graduated, this is 0.1. Now, but the question here now asks me, what is the probability of graduated and happy? Here, they don't ask me about the conditional. The conditional is very easy. I can find it from the tree diagram. They ask me now about graduated and happy. Now, let's come back here. Look at this one here. If I want to find the probability of B given A, you have to say it is A and B over probability of A. So if you have to find probability of A and B, shall we make a cross product? If yes, my yes, hey, yes or no? Yes. So we have to say
yeah.
it is the probability of B given A times probability of A. So the probability of A and B in the conditional probability, we can find it by multiplying probability of B given A times probability of A. So let's use this one, this formula here, to solve the tree diagram. So the probability that is graduated and happy is the probability of, where is graduated and happy? Which branch I'm talking about them? Graduated and happy. I'm here.
The upper one.
It's 0.9.
First one here. Yeah. Here now, this 0.9, they told me about the, let's write, don't have a space. Okay. So let's write them now as probability of, here what did we have? Did we have happy given that graduated, or graduated given that happy?
Graduated.
Happy
Graduated.
given that graduated. Times. Then I told you the probability of B given A is A and B over the probability of A. So here we have probability of H given G is the probability of H and G over the probability of G. So if I want to find now the probability of H and G, we have to say it is the probability of H given G times the probability of G. So here also, since we end with G, we have to multiply by the probability of G. Is it clear?
Yes, we got it from cross multiplication.
Yeah. So here, since I end with G, I have to multiply with the probability of graduated. Now, what is the probability? Now, from the tree diagram, what is the probability that is happy and given that he's graduated?
0.9.
It is
No,
0.9
0.9.
times.
0.9.
What is the probability that of the graduated one?
0.85.
This one here
0.
shows the probability of graduated, which is 0.85. After you multiply them, you will get 0.765 or 76.5%. Is it clear?
Yes.
Yes.
Thank you.
Now, with the same one, let's solve this here. Didn't graduate and happy. Let's come back to solve it here because I need the tree diagram. So remember, they asked me about they asked me about not to graduate and happy. So what you have to say here? Happy given that not graduated times the probability of not graduated. Is it right?
Yes.
Happy given that not graduated, we have 0.6. And the probability of not graduated, we have 0.15. Is it right, miss?
Yes.
Yes,
Yeah.